For order of operations review, I like GEMS. And here's, the G is the big reason. G stands for grouping. Which, grouping has a bunch of different things. And I'm going to write it off to the left here. You guys probably know these. Parentheses, right? You probably also know brackets. They're kind of the same thing. Brackets and parentheses don't mean anything different. People use them both for organizational purposes. I personally will just double up parentheses when I do stuff. But some people like to use brackets to differentiate. There's also going to be, and I'm doing this like this, those like lines on the outside, that's absolute value. So stuff inside of an absolute value, that's a grouping symbol. What is the absolute value of something? It's not the it's not the opposite. It is the distance from 0. So distance is always positive. So your quick review for absolute value is the absolute value of both 4 and -4 is 4. Distance is always positive. So if there's absolute value symbols, you need to do the operation on the inside first because it's a grouping symbol. All right? And then there's not a great way to write this, but if there's operations in a numerator or denominator of a fraction, that's grouping. You'd have to simplify your numerator and you'd have to simplify your denominator first before doing the division. Okay? So even though there's no parentheses around that x plus y or that 2a, you would have to do your addition or multiplication before you do your division for the fraction, okay? It's just like having parentheses. This is the same thing as this. Does that make sense? We just don't use parentheses. You don't have to use parentheses. That is grouping. And then the last bit of grouping that we're going to worry about would be stuff happening under a square root. Sometimes you will see it in parentheses. Sometimes you won't. But if stuff's happening under a square root, like multiple things, that is also grouping. So that's the big reason I like GEMS. Look at all those things that fit under grouping, right? And if you're
what
using,
if there's 2 of them happening at the same time?
yeah,
Just
so
do the first one?
well, usually at the same time there might be multiple spots you can go left, right, or sometimes there's parentheses or something inside of something. So you have to go to the one most inside. So if the whole thing's in a parenthesis, then you have to. Sometimes there are parentheses in that, parentheses in that. You have to go to the most inside parentheses first. Okay, good question. The E. What does E stand for?
Exponents.
Exponents.
Does that count as square root too?
Yeah, slash. So now we know the inverse operation, roots, which we've only been rocking square roots so far, but there are other roots. They would happen at the same level. There are cubed roots, fourth roots, fifth roots, 2/3 roots, bunch of roots. Okay? But they always happen at the same level, square roots and exponents. M stands for?
Multiplication / division.
Yeah, multiply / divide, and you're going to use left to right. Here's another reason I like GEMS. Notice they're at the same level, right? Multiply, divide under that M. So it kind of encourages you to use that left to right a little more, I think. And then S stands for subtract and addition. Subtract and add. And again, that's going to be left to right. Cool? So if you haven't used GEMS, if you haven't used it and maybe you're not comfortable with it yet, can you see why I kind of vibe with it? It's that G. Yeah. And then the multiply, divide being the same level, subtract being and add same level. It's going to encourage that left to right. And I know, like, if you're using PEMDAS and it's fresh, my concern is, like, you don't, like, think about it for a few years at some point, and then you go back to PEMDAS, and then you misremember what to do with it. You might remember PEMDAS, but not how to use it, kind of thing. I think this encourages you to use it right. Yeah.
Okay, so in PEMDAS, not talking about GEMS,
Yeah.
would grouping count as parentheses?
Yeah, it would be like parentheses and grouping.
Okay.
Yeah. So it's really the same thing. So let's look at that. Those are the same. That's the same. And then these would be like the same. Okay? You see, it's the same thing. If you're going to memorize one and then use it later without practice, I think GEMS lends itself to being more accurate later. And that grouping has a million things in it now. All right? Cool. And so what I'm going to do is have you try this out. Then I'll do it, and I'm going to show you an organizational strategy I use. Example 2, I'm going to have one of you teach it to us after we get example 2. You can get YouTube famous, you know. You can mark your time in the comments, share it with all your friends, okay? And I'm going to take you through an organizational thing I like to do. Some kids do this, and I'm all right with this. They'll be like, G is grouping, so they'll start doing all the grouping. So notice on this problem, though, there's brackets and parentheses. So you have to go on the one that's in the inside. And so I'm only focusing in on here. So what would I have to do first in here? James?
Exponents.
Exponents. So once you're inside, it's like its own little world, and you have to use order of operations in there. So I underline the operation I'm going to do, and I rewrite everything else.
Oh, yes.
And it's like some work, but I'm going to let you know you make less mistakes doing it this way. Next, I have multiply, so I underline that. Next, I have parentheses still of subtract. Next, in brackets, I have multiply. Next, I have exponents.
I did it.
For 1600. Now, here's the deal. I know this seems like a lot of work. Is any one step super crazy hard? Any one step? No. And how can you tell what I did each time?
Lines.
That line. So if you were to do it and you got it wrong, if you used a similar organizational strategy, you could tell exactly where you did something different than me. And that's where you learn, all right? So that's why I'm all about this organization. I'll let you know, as a former algebra student, I like to do a lot of stuff in my head when I was a kid. And I'd get answers wrong sometimes. Like, especially on a quiz. I'd rock like a B on a quiz once in a while, but I like knew how to do stuff. But then I couldn't figure out what I even did wrong. Once I decided to take my teacher's advice and do two things. Show all my work like this or communicate what I'm doing. I would catch mistakes and draw pictures when I didn't understand something, like situational stuff. I started going from that B once in a while to just owning an A's all the time. Once I started writing stuff down and drawing pictures, those two things. I don't know why it took me till 8th grade to buy in. In 8th grade, I bought in, and I went from that getting that A- once in a while for a trimester, just smoked everything with A's forever after that. The two things I changed were communicating what I was doing on paper and drawing pictures. That's all I did to start owning it. Okay, so here's this problem. I'm going to hand this off to a student to explain to us in a moment. I want you to be mindful of the base of your exponent. You guys go. We're going to hear how to do this one.
Okay, so first you do 3 to the power of 2, so negative 9.
Yeah, and that has to be a negative 9 because it's the opposite of 3 squared. No parenthesis around that base, right? Okay.
And then negative 5 minus 13 is negative 18. Oh gosh.
When people are doing those integers, anybody thinking about that fighting and hugging stuff? No?
Sometimes. Negative divided by 6 was
Positive 2, there we go, thank you.
That writing
negative divided by negative.
Well, here is a hint. Because the pencil and stuff is smart, you can actually rest your hand on the screen and it won't. Next time. So next example, this one I picked because it has absolute value, which is one of our new grouping symbols. So remember, you have to do absolute value first. Like, it's with grouping, and absolute value just means distance from 0. Start rolling through this one. So the first thing I need to do is the grouping inside the grouping. So the absolute value of 2 minus 6, or I have to do the 2 minus 6, which is negative 4. So next I need to do the absolute value of negative 4, which is 4. All right? Now I've got add, subtract. I'm going to go left to right. I got parentheses still. 4 times 4 is 16. All right?
Yes.
If you got it wrong, cool. Figure out what you did different. Ask a question. So the first thing I'm going to do is under the square root, because that's grouping. So negative 16 plus 4 over 2 times the square root of 9. It's 13 minus 4 is 9. So the next thing I'm going to do is exponent root, right? So I have a root here. So negative 16 plus 4 over 2 times 3. And now I need to do grouping which is in the numerator. I have to do the whole numerator, whole denominator. So I'm going to go up here. I get negative 12 over 6 for negative 2. All right?
Oh, I did.
And guys, I'm actually a fan on tonight's homework. For tonight's homework, after you get an answer, I don't care if you use that app, PhotoMath. If you write neatly, it'll solve the answer for you. And if you're wrong, it'll even say steps, and you can figure out where you went wrong if you show your work well. Kids know about PhotoMath?
Yeah. Yes. I have it.
Yeah, some kids think, haha, I'm going to cheat. But if you just PhotoMath everything, you're going to get ruined on a test, right? So it's a good way to check stuff. I actually advocate for the use of it as something to check. If you haven't used it, it's pretty easy. You just use your phone's camera and you hover over your work. And if you write neat enough, it'll recognize what's what and tell you what the answer should be.